now I want you to think about this equation. Negative 2x squared plus 5x minus 7 equals to 0. Solve this graphically. Okay? Solve, thank you, graphically. You don't need to plot it out, you just need to tell me what to plot. So your answer will be telling me what to plot lah. Okay, first equation you should plot, what is it? Y equals to plus minus 7. Okay, second one will be y equals to 0. Anybody any questions, any doubts at this point? No? Okay, then how do we plot the first graph? We need to draw a table. We need to have values. So this x, this is y. So if the question says it is the range of x is from -1 to 4. So I'll start with -1, 0, 1, so on and so forth until 4. I get corresponding values of y, which is -14, -7, -7, -4, so on and so forth until -19. Okay, then I plot it out. Okay, and I have y equals to negative 2x squared plus 5x minus 7. Okay, now I have my graph. Looks like this. Okay, it is a parabola opening downwards. Do you know why? What is negative? The coefficient of x squared is negative, so it opens downwards. Then I am supposed to plot my other graph, right? What is that equation? Y equals to 0. But before I draw that in, do you foresee any problem? Do you agree? The graph is not going to touch the x-axis, right? I mean, yes, it is not going to touch the x-axis. So over here, y equals to 0. Let's just convince ourselves. Okay, the blue line. What did I always say about the point of intersection? What does the point of intersection tell you? The solution for x. Then where is the intersection now? If I zoom out, do you think it will cut the x-axis? I can keep zooming out, it will not touch the x-axis because it opens forever and ever downwards. Then the maximum point for this curve, the maximum point is -3.875. It cannot go bigger than this. So it will never ever touch my x-axis. So what can I say about the solution? Yeah, I can say no real roots, or I can say no solution. So since two graphs do not intersect, then I conclude that negative 2x squared plus 5x minus 7 equals to 0 has no real roots. Okay, now this phrase over here should sound familiar to you. No real roots. When did we see this before? When did we see this phrase? No real roots. We saw it in our quadratic formula. Can we try solving this with our quadratic formula? Then we see whether both of them agree with each other. Can we try solving this with our quadratic formula? Write it down. So which part of the equation gives you a math error? The square root of a negative number. As long as you square root a negative number, your calculator will just tell you math error. So that tells you there is no solution, which is shown by this graph, this quadratic graph, and the graph of y equals to 0. They do not intersect. That's why there are no solutions. Why do I want to do that, is it? So that I can plot a graph. If I do not put a y over here, if I don't plot y equals to so on and so forth, then there is nothing that I can sketch for this graph. How am I going to sketch a graph that is highlighted over here if I only have one variable? There isn't a y, right? So if you try to do a table over here, you only have x values. Then you don't have y values. But only maximum 2x values will fit into this equation. And you're not going to be doing trial and error all the way. That is why we let y be equals to the left hand side, we let y be equals to the right hand side, then we plot the two graphs. Where they intersect will be my answer. Any other questions? Why is your calculator weird?
Use the calculator method, right?
Ah. What did they say? So I told you, you need to know what you're doing, right? You try lah. You try doing this during your exams, you see what happens. So at the start of quadratic equations, I told you that there is a shortcut that you can use your calculator. You just select the appropriate function, key in the value of a, b, c, and it will magically give you the answer. If you just write that down, you will get 0 marks because you haven't shown me any working. By working, I mean I want to see either your quadratic formula or your factorization or you're completing a square. You cannot straight away give me two numbers as the answer. You will get 0 even though it is correct. And sometimes, for this type of equations, you try keying it in, your calculator will give you something that you do not understand. There is something with an I at the end. Do you notice that? What is the I for? No, not infinite. You can try with your calculator now, those of you who know that method. When I say that this one has no real roots, that means they are imaginary roots. Not real, imaginary. That's what the I stands for, imaginary. So if you don't know what you're doing, you just write down the answer, too bad, you're going to get 0. Okay? So I don't encourage using that at all. Now, next example that I want you to try is, oh, by the way, what we just did was example 8 in your textbook, page 104. Exactly the same thing. Okay, you can try and read it yourself. Everything that has been covered is shown there. Okay, let us go to example number 9. Draw the graph of y. Okay, so these are type of question they can ask you. Part A, draw the graph of y equals to x squared minus 2x minus 3 for x between -2 and 4. Yes? Right, so they gave you a range to plot, okay, this graph. So your table of values, I will see x and y from -2, -1, so on and so forth, until 4. Then you get the corresponding values of y, shown in your page 106, then you plot it out. Your homework is going to involve a lot of plotting, so go and buy your graph paper, get a long ruler, get your flexible curve or your French curve, and plot and sketch your graph. You need to practice. Because this type of questions, a lot of marks will be allocated to it. Even if you score very well for the other questions, you do badly for this one, you can say goodbye to your A. Okay, so this is y equals to x squared minus 2x minus 3. Okay, so my graph, as expected, it is a parabola opening upwards because the coefficient of x squared is positive. It is 1. Then they ask you to use this graph that you have drawn to find the values of x, for which this is part B now. Oh, this is programming. Okay, so B. Say again? Who know how to draw what? How the human? Have then there's x. You also plotted in your homework. Oh, how they create a program? Okay, the easiest way is when I key in this one, right? Then the program, they will start creating a table. Then they will substitute in values of x. They have a calculator, right? I mean, your calculators run on programs. It is not surprising that there is a program that calculates all these values. Then the program plots everything out and it joins them up. That's it. Okay, which value of x do you want? Graphical, which value of x you want? Suppose we are interested in x equals to negative 2 over here. X equals to negative 2, they will tell you that the value of y is 5.06. That means they have already calculated everything over here. When x equals to negative 1.34, y is equals to 1.476. You can substitute it into the equation to check whether they are correct or not. But I'm sure they are correct. Okay? Yeah, okay, never mind. B part 1. Now we are supposed to use this graph to find out the values of x, for which x squared minus 2x minus 3 equals to negative 2. What should we do then? What should we do? I already have the one graph over here. It is y equals to x squared minus 2x minus 3. So Ali is saying we should plot another graph, and that will be, what is the other graph I should plot? Y equals to negative 2. Okay, if we do that, what are we looking out for? The points of intersection. How many points could there be? There could be 2. Any other possible answers? There could be 1 point of intersection also, right? When it just touches this part, and there could also be no solution. Okay, either 2 maximum solution where it cuts 2 times, or 1 solution which is repeated, it just touches the minimum point, or no solution if it doesn't even cut at all. So right now I'm going to plot in the graph of y equals to negative 2. So y equals to negative 2. Okay, over here, orange color. How many points does it cut your curve? 2 points. What are the solutions? So if you had drawn it out properly, you will get negative 0.404 as well as 2.414. Okay, so just in your page 106, B part 1 over here at the side, write down plot y equals to negative 2. Write down plot y equals to negative 2. Because the point of intersection will tell us the solution. Okay? And at the bottom of page 106, the graph that is shown is the same one that I have on the screen. They plotted y equals to negative 2 they found the x coordinates of where they intercepted. So meaning x equals to negative 0.4 as well as x equals to 2.4. These are estimates. Because we didn't calculate, we won't have the exact value. And when you draw your graph, sometimes your graph is not perfect. So your answers from the graphs, they are just estimates. Okay? Your textbook tells you that from the graph we have negative 0.4. My program is more powerful. It tells me that it is negative 0.414, 3 dp. And they are very sure of that. But in actual fact, there are more decimal places. It is more decimal places than these three. There's more, okay? They just truncated it at 3 dp. Whereas your textbook, they truncated it they round off at 1 dp. Okay? So that's for part 1. Now, part 2. B, part 2. They want you to solve x squared minus 2x minus 5 equals to 0. Okay, what should we do? Again, we have this graph already. Y equals to x squared minus 2x minus 3. What graph should we draw in order to solve B part 2? What do you think? You mean sketch a quadratic graph? Okay, what graph should we draw for this? This one is different already. What parabola should we draw? Okay, it opens upwards, but what is the equation of this parabola you want me to draw? Y equals to x squared minus 2x minus 5, is it? That's the first one. Then the second one, what do you want me to draw? Y equals to 0. Then you're going to create another table of values, right? X and y for your parabola. Then after that, you will draw the y equals to 0, which is the x-axis. Isn't that very troublesome? What if I tell you, so everybody listen carefully, what if I tell you that I can make use of my existing graph, this one, y equals to x squared minus 2x minus 3. Then you don't need to plot another, you don't need to do another table of values. You don't need to plot another parabola. You can use the same one. You want to know how to do it? Yes, you want to know. You better know. So instead of just plotting a new graph, I am going to try to make my left-hand side, this is the left-hand side, this is the right-hand side. I'm going to try to make the left-hand side look like this yellow color part. Okay? You all have learned how we do something to the left-hand side, then you must do something to same thing to the right-hand side, right? You add 3 here, you minus 3 here. You times 2 here, you divide, you times 2 there. So on and so forth. Now, I am going to do the same thing to change my left-hand side to look like the yellow color one, because that is the graph I already have, and I don't want to waste it. So what should I do to the left-hand side to make it look like the right-hand side? To look like this side? Think about it. What should I do to this side in order to make it the same as this yellow color part? Plus 2 on both sides. Because if I add 2 on both sides, you see what happens, Plus 2, plus 2, I will get x squared minus 2x minus 3 equals to 2. Right? Agree now, how? If I add 2 to both sides? Then, isn't this the same as all these highlighted parts? That means I already have the graph for this, right? Then what graph do I need to draw now in order to find the solution? Then we draw, the next step will be, we draw y equals to 2. Is it easier to draw y equals to 2 as compared to draw one whole parabola again? Definitely. What? Okay, hold on first. So, if you plot y equals to 2 over the same graph, y equals to 2, then this is the graph I will get. One line, but my original parabola stays the same. Now the points of intersection they are going to be the solution again to this equation in red. What x squared minus 2x minus 5 equals to 0. The solutions over there are negative 1.449 as well as 3.449. Okay? So Roberto, which part you need clarification? B part 2. Okay. This question, example number 9. First, part A, they ask you to draw a parabola. Okay, look at it. You are supposed to draw the graph of y equals to x squared minus 2x minus 3. That is the only parabola they ask you to draw. Then, in B part 1, do you understand how to do it? B part 1, asking you to solve the equation of x squared minus 2x minus 3 equals to negative 2. So we've been through the drill. We put the left hand side to be y equals to that thing. And then y equals to negative 2 on the right hand side. So where these two graphs intersect, that will be your solution to x. Yes, yes. It is still the same concept. Then, that's for part 1. For part 2, the parabola looks a bit different. X squared minus 2x minus 5. Whereas what we plotted was minus 3, right? But now they have one that is minus 5. So we do not want to go through the trouble of plotting another parabola and plotting the graph of y equals to 0 in order to find the solution. So what we can do is to change the equation from x squared minus 2x minus 5 equals to 0. I add 2 on both sides such that I will get x squared minus 2x minus 3 equals to 2. These two equations are the same mathematically. They may not look the same, but they are the same. Because if I minus 2 on both sides, I get back my original red equation. Okay? Then because I already have the graph of x squared minus 2x minus 3 equals to y over here, I'm not going to waste it. I am just going to draw the graph of y equals to 2 onto it and find the points of intersection to get the solution for x. Yeah, it's just going to be x equals to negative 1.449. The x coordinate is the solution. Because your coordinates, you have two, you have x and y, but we are not interested in y. Because y is something that we introduce ourselves in order to get the graph. We are only interested in the x values, which is negative 1.449 and 3.449. In your textbook on page 107, they plotted the same thing, y equals to 2. And their values are negative 1.5 and 3.5, which is quite close to what I have from my program. Okay? So I want you to do the same thing in B part 2. Write down, plot y equals to 2. And you better know why we do that. Reason is as shown over on my screen. Okay, finally, the last one. B part 3. To solve x squared minus 2x minus 3 equals to 2x minus 4. Tell me what we should plot. Do we already have that? Okay, very good. Since we already have that, I will plot y equals to x squared minus 2x minus 3 as well as, sorry? Yep. So these are the two graphs that we will plot. The first one is already given, is already done in part A. So this is the same one again. The other graph we have to plot will be 2x minus 4. Their solutions will be, the point of intersection will be the solution. Okay, just going to do it quickly over here. Y equals to 2x minus 4. You get a straight line sloping upwards because the gradient, meaning the coefficient of x, is positive. So it slopes upwards. It intersects the y-axis at -4. Because that is shown, y equals mx plus c. And how many points of intersection do we see? 2. They are here. One over here and one over here. Which value are we interested in? X values only. So 0.268 as well as 3.732. The y value, don't care. We don't need that. So in your textbook, they have x equals to 0.3 and 3.7. Quite similar to these more accurate, more precise values. Okay? So in part 3, at the side, write down, plot 2x minus 4. And everybody knows how to plot 2x minus 4. You can construct your table of values also. Then you substitute in values. Yes, this one you have to plot because it is no longer just a horizontal line. It has a gradient more than 0 or less than 0. You can choose anything as long as you give me a straight line that passes through y equals to -4 and has a gradient of 2. Okay, final one is example 10. Okay, anyway, let's do try it 9. Okay, I'm going to call some bored students to help me tell me what I should plot. So bored students are the ones who put their heads on the table right way out. Okay, try it 9. Draw the graph, part A, y equals to 3x squared minus 2x plus 4. Then we have a table of values, x and y. Final one will be 3. Then we get values. To make things easy for him, I am going to use this program to plot. So y equals to 3x squared minus 2x plus 4. 3x squared minus 2x plus 4. Okay. So why parabola? Opening upwards, because coefficient of x squared is 3. It is positive. And we notice that it didn't cut the x-axis. But doesn't matter. We know how to deal with it. If they ask us for the intersection point between the x-axis and the graph. Okay? So now, part 1, B part 1. Use the graph to find the solutions for which 3x squared minus 2x plus 4 equals to 12. Wei Hao, what do you think we should plot? Which is already done. Then? Okay, so that is correct. Please write it down. Plot y equals to 12. The points of intersection will be the solution. Okay, so over here, green line, y equals to 12. So you can just jot down this answer. What answer will you jot down? Yep, jot down -1.333 and 2 beside the question. So if you go and try it, you can check whether your answers are correct or not. But that's not all. We still have part 2, which is more challenging. Think about it. What should we plot for part 2? You need to use your pencil, you need to scribble. Unless your mental sums is very good. Okay, we already got the answer. What do y'all think? What did y'all try? Kai, what do you get? What should I plot? What should I plot? Part 2, I have to solve 3x squared minus 2x minus 3 equals to 0. So what should I plot? Hey Kai, I'm still asking you. You already got part of the answer. The rest, who's not done? Can you tell me what you did to both sides first? He added 7 to both sides. Plus 7 over here. Over here. Plus 7. So he got 3x squared minus 2x. What is negative 3 plus 7? Get plus 4, right? Equals to 7. Why did he choose to plus 7 on both sides? Because he wanted this part, which we already plotted earlier on. Wait, try it 9. Which we already plotted. 3x squared minus 2x plus 4. 3x squared minus 2x plus 4. So now that we have the graph, what is the other graph I need to plot? Yeah, y equals to 7. So I plot y equals to 7. The point of intersection will be my solution. So over here, y equals to 7. Okay, you saw how the green line was moving when I move this around. Okay, y equals to 12 over here, y equals 10, then y equals 7. And the points of intersection are this. So copy down the answer. This is a skill you must get it correct. This skill will definitely be tested. And finally, part 3. Oops. We want to solve 3x squared minus 2x plus 4 equals to x plus 6. I think this is easier than the previous question. What should we plot? Yeah, just plot y equals to x plus 6 because the left hand side is already the same as what we had in our graph. So y equals to x plus 6. Okay, two solutions. Over here and over here. Copy down the solutions. Done? Then I have my own question. My own one is part 4. Solve okay, this one is harder. Okay, how? What are we going to plot? What are the graphs that we're going to plot? So try this. You need to write it down. You need to work on your textbook. Who finished already? What's the answer? You finished already. What's the answer? Huh? So what are you going to plot? Wrong. Wrong. go and do it on your book. Don't go and use your mental sums. Anybody else finished already? You need to tell me which graph to plot. Francis, help her. Done? Okay. Who needs more time? Okay, continue. Try to work faster.
So y equal to 21 minus 3x.
Sounds like it. Okay, so right now I'm going to show you the solution. My goal is to make it look like what I already have. So my graph was 3x squared minus 2x. Over here I have a plus x. So in order to change the plus x to become a negative 2x, I need to minus 3x. Okay, so I'll minus 3x on both sides. Minus 3x. So I'm left with 3x squared minus 2x minus 12 equals to 5 minus 3x. Okay, so now my first term and the second term, they are the same already as my graph that I had. Then I need another step. What do I need to do to make the negative 12 look like a 4, to become a 4? I need to add 16. So I end up with 3x squared minus 2x plus 4 equals to 5 minus 3x plus 16, which is 21 minus 3x. Okay? Then my left hand side is already the graph that I have. And all I need to do is to just plot y equals to negative 3x plus 21. Find the points of intersection and get the answer. Can? What do you think this graph looks like? It is a straight line. Okay, it is a straight line. Y equals mx plus c. How does it slope? Upwards or downwards? Downwards. Why? Because there is a negative 3 over here. What is the y-intercept? 21. Okay, so let's see whether all these make sense. Y equals to negative 3x plus 21. Okay, I have a straight line sloping downwards, cutting through 21. And these are my solutions. X equals to negative 2.553 as well as 2.22. This. Yes, you need to draw your table of values. Okay? Now everybody knows how to decide what graph to plot. Let us conclude this portion. How is this useful? And how is this similar to what we have learned previously? If today, if 2 weeks ago, I asked you to solve, 2 weeks ago if I asked you to solve this, what would you do? Do your quadratic formula, right? But before that, you can't just apply your quadratic formula here. What do you need to do? Huh? You need to make it equal to 0. Can you try that now? Can you try that on another blank space? This orange color one. Try solving it with your quadratic formula. Before that, you need to make it into the form of ax squared plus bx plus c equals to 0. Then you use your minus b plus minus square root b squared minus 4ac over 2a. Yeah, try it now. Try, hurry up. 3x squared minus 2x minus 12 equals to 5 minus 3x. No, sorry, not this one. The original formula, the original equation is this one. This one. 3x squared plus x minus 12 equals to 5. Change this into your ax squared plus bx plus c equals to 0. Then what do you get? The orange one. Change the orange one into ax squared plus bx plus c equals to 0 and solve using your quadratic formula. That's why I want you to see that. You need to work it out to see it. Work it out. Do it.
Yes,
1.8400. 1.8402. Are you sure? What do you get? That's the graph, right? Afiq, do you get these numbers or not? If you didn't, that means you press wrongly or you write wrongly already. Uncle, do you get it? Okay, so this one, I have to make it in the form ax squared plus bx plus c equals to 0. That means I will have 3x squared plus x minus 12 minus 5 equals to 0. So 3x squared plus x minus 17 equals to 0. X equals to minus x equals to minus 1 plus minus square root of 1 square minus 4 times 3 times negative 17 over 2 times 3. So you get negative 1 plus minus square root 205, is it? 205 over 6. And you get two answers. 1 plus square root 205 divided by 6, get 2.5529, or negative 1 minus okay. The other one, what do you get? 2.21, is it? 21 some more? 9. Okay. Then after that you round it off, you get 2.2, sorry, 2. Oh, sorry. Negative 2.553 or 2.22. Okay? And this is what we see from the x coordinates of the points of intersection. So whatever you have learned in the past, it is applicable and it is shown in a graphical form this way. Okay? Now I have one last question to go through from your textbook, which is example 10. Yes. Okay, I'll clear these. Example 10. You are given a diagram with a graph. In this graph, in this question, you don't need to plot anything. Oh yeah, wrong color. Okay, orange one. Sorry, give me some time, huh? B and blue. Okay, find the coordinates of A, B, and C. This orange curve has the equation of y equals to negative x squared plus x plus 12. How am I going to find the coordinates over here, A, B, and C? What should we do? What is so special about the coordinate A? The x coordinate is negative. What else can you tell me? Y equals to 0. At A, y equals to 0. Okay, that is the first piece of information that we can get. I'm going to substitute into this equation, equation number 1. So 0 equals to negative x squared plus x plus 12. So now I have a quadratic equation, ax squared plus bx plus c equals to 0. I want to solve for x. How many methods do you know now? 4. Okay, but which one is the most tedious? Drawing a graph. So if you have a choice, then don't use the graphical method. What is the method you prefer then? Okay, you all like the quadratic formula because it always works. So x equals to minus 1 plus minus square root 1 square minus 4 times negative 1 times 12 over 2 times negative 1. And our solution will be negative 3 or 4. In fact, we can actually use our factorization, which is what the textbook used. Factorization, you get x equals to negative 3 or x equals to 4 as well. Okay? So now, what does this negative 3 and this 4 represent? What does it represent on the graph? The x-intercept. Does this negative 3 belong to A or does it belong to B? Because it is smaller, right? So the coordinates of A will be, over here will be negative 3. Then the full set of coordinates for A will be negative 3, 0. Then what is the x-intercept over here? 4. So the coordinates for B will be 4, 0. Okay? Then what about at C? Yes. At C, x equals to 0. So we substitute that in. Isn't it even easier? Sub into equation number 1. So y equals to negative 0 square plus 0 plus 12. Answer? What's the answer? 12 lah. So this must be 12. So coordinates for C will be 0, 12. Okay, now we have the coordinates for A, B, and C. Part B. They ask us to find the length of BC. Over here, find this length. Then you use your formula for length of line segment, which is, you cannot recall, is over here, square root of x2 minus x1 square plus y2 minus y1 square. Okay, your length of line segment. And then finally find the equation of AC. This is what we will do for part B. Then for part C, to find the equation, we need the gradient. Find gradient using y2 minus y1 over x2 minus x1. Since you have the gradient, what we need next will be the y-intercept, which is 12. Then done. Okay? Very straightforward. It's just you need to know and remember how we found line segment and how we found the equation of a straight line. So with that, we have come to the end of chapter 8.2. And your homework question to add on. Yesterday I gave you question 1 and 2, right? So you will continue with 3, 4, 5, 6, 7. Need to practice. So I will expect 7 graphs. Why? What's wrong? What do you mean how to block? Huh? You just give the decimal.
I mean, you can just use the decimal one or decimal.
You can use decimals as a reference, but you are still expected to draw the table and plot yourself. Sorry?
Sure. But you know how to find the half one.
Discount. So I should do charity work for you, is it? Okay, let me think. I will remove question. No lah. I will remove question. Okay lah, question 6 . Yeah, one only. No. I'll remove one question. This is for your own good. This is due on Monday, yes. Monday your lesson, right? Oh, then Tuesday. Due on Tuesday.
The half square is something like.
Huh?
It's not from round.
Sorry?
Half square is different lah.
Same thing. What's the difference? Whether it is.
Like that and then like that.
No. Don't go and mix. When do you learn that? When do you hear about that? See? Any